The first one we're going to start with today is a bar diagram. We've used bar diagrams before with both addition and subtraction. I'm going to real quick show you an example of addition and subtraction and how we've used this, and then we'll go into multiplication. So if I was going to add two numbers together, like 52 plus 12, if I needed to show that in a bar diagram, I would show 52 plus 12 equals some number. My missing number we'd show on top. So I would replace my question mark with 64. That's how we use the bar diagram with addition. For subtraction, we might show something like this. If I had 64 minus 52, I would put 64 on top, show 52 here, and my question mark would be here. We're showing parts to make a whole with both addition and subtraction. The children are familiar with bar diagrams for addition and subtraction. For multiplication, we try to show them that they're equal parts. So I'm going to move to a new problem of 23 times 2. In this problem, I want to show the students that I'm going to have two equal parts of 23 together to make some mystery number. This is helping them to connect that multiplication is really repeated addition of equal parts. 23 plus 23 is the same as 23 times 2. I could replace my question mark with 46. The next strategy we're going to use is area model, and we're going to use drawings of our place value blocks. Again, the children have a lot of experience with place value blocks. We go over with them that a square equals 100, a rod equals 10, and an X or unit equals 1. That's just information they need to know to be able to use area model to solve multiplication. We're going to use our same problem, 23 times 2, to draw this out. So 23 times 2, I have two tens, so I'm going to draw two rods, and I have three ones. So I'm going to draw three ones. That is 123. I need two 23s. So I'm going to draw it again. I have two tens and three ones. Now I can look at everything that I have here. I have four tens and I have six ones all together. So what do four tens mean? What do four tens represent? Four tens is like saying 40. What do six ones mean? 6. Together, 40 plus 6 equals 46. The next strategy we're going to use is expanded notation. The students learned about expanded notation in the beginning of the year when we explored place value. Quickly, I'm going to show you how we used expanded notation earlier in the year. Here's the number 326. We have a 3 in the hundreds place, a 2-digit in the tens place, and the 6-digit in the ones place. This 3 right here represents 300. This 2 represents 20, and the 6 represents 6 ones. So we have 300 for the 3-digit in the hundreds place, 20 for the 2-digit that's in the tens place, and 6 for the 6-digit that's in the ones place. 326, written in expanded notation, is 300 plus 20 plus 6. Carrying that to multiplication, we are going to look at our same problem of 23 times 2 using expanded notation. We've got a 2 in the tens place. That 2 represents 20. we have a 3 digit in the ones place. That 3 represents 3 ones. 23 times 2 is saying this expanded notation, 20 plus 3, 2 times. The first problem I'm going to do within this problem is 2 times 3. 2 times 3 is 6. Now I'm going to move on to my tens. 2 times 20 is my next problem. 2 times 20 is 40. Together, when I add them up, I have my same answer, 46. The next strategy we're going to use is the generic rectangle. Again, we're going to rely on their skills of expanded notation. The same problem, 23 times 2, is the problem we're going to use. I'm going to think about what this 2 in the tens place represents. That 2 represents 20. Then I'm going to think about what that 3 in the ones place represents. 3. I need to see 23 2 times. Over here, I'm going to write how many times we're going to see 23. I'm going to divide my generic rectangle in half. This is representing my ones, and this is representing my tens. In this column, I'm going to have 2 times 20. 2 times 20 is 40. In this column, I'm going to have 2 times 3, which is 6. 40 plus 6 equals 46. The last strategy we're going to use is a traditional algorithm. 23 times 2. This is probably the way that your parents learned how to do multiplication. I'm going to start with 2 times 3 is 6. 2 times 2 is 4. My same answer of 46. I'd like to show you these 5 strategies again, but this time with a more difficult problem that shows regrouping. I'm going to again go back to my first one, which is my bar diagram, connecting the students to repeated addition, that multiplication is repeated addition. My problem I'm going to do is 45 times 3. So I need to show the students in my bar diagram that I have 3 equal parts of 45. 45 times 3 is really just saying 45 plus 45 plus 45. And I'm going to add this up. 5 plus 5 plus 5 is 15. The 5 goes down and I'm regrouping. 4 plus 4 plus 4 is 12, plus 1 more is 13. 135 is 45 times 3. The problem is the same, 45 times 3. I'm going to draw this out. 45. There's 4 in the 10 spot, so I need 4 rods. There's a 5 in the 1 spot, so I need 5 ones or 5 units. That is 45, but I need 3 of those. So I'm going to draw it 2 more times. This drawing shows 45 3 times. Okay, so let's see what I have here. I have 15 ones and I have 12 tens. Well, I need to do some regrouping. I can't have 15 ones. So I'm going to take 10 of these ones and regroup. these 10 ones, these 10 units, can become 1 10. Now I have 5 ones and 13 tens. I still kind of have a problem though. I can't have 13 tens. So I'm going to regroup. I'm going to take 10 of my tens and make a 100. Now I have 5 ones, 3 tens, and 100. And I can add those up. What does 100 look like in expanded notation? Plus 3 tens plus 5 ones. Together, my same answer of 135. All right, let's look at 45 times 3 in expanded notation. The 4 digit in the 10 spot represents 40, and the 5 digit in the 1 spot represents 5. I need to take 45 and times it by 3. My first step is to say 3 times 5. 3 times 5 is 15. My next step is to multiply the 10 spot, and that's 3 times 40. 3 times 40 is 120. I take these two partial products and add them together. 5 plus 0 is 5, 1 plus 2 is 3, and 1 plus nothing is our same answer of 135. Let's look at 45 times 3 with our generic rectangle. I'm going to write my problem at the top, and then think about this problem again in expanded notation. The 4 digit in the tens place represents 40. The 5 digit in the ones place represents 5. I need to take 45 and multiply it by 3. In my first box, I'm saying 3 times 40. 3 times 40 is 120. In my second box, I'm saying 3 times 5. 3 times 5 is 15. Now I'm going to take these out of my generic rectangle, 120 plus 15. Because this is a more difficult problem, I'm going to also write it vertically. 0 plus 5 is 5, 2 plus 1 is 3, 1 plus nothing is my same answer of 135. We're finally back to that traditional algorithm, 45 times 3. It's important to note the reason we don't skip right to this algorithm is that the children need the background and the fundamentals of all the other steps to truly understand what they're doing. This algorithm is a shortcut. We're saying 3 times 5 is 15. The 5 goes down and we regroup the ones. So the children understand that it's not just 3 times 4, that really we're saying 3 times 40. It's part of the reason why we do all those other strategies. 3 times 4 is 12, plus 1 is 13. I know it seems like that's a lot simpler, but really all the other strategies help to build a solid foundation for multiplication.